So last class আমি discuss করেছিলাম যে how a heat engine works. Heat engine basically works in a cycle. Now that cycle may be different from different heat engine, but it must work in a cycle. It must complete in a cycle. That means each cycle will produce a work done, and while the cycle repeats, you are getting the work done continuously from the heat engine. So to run a heat engine, we have to run the processes of extracting heat from the source and given to the sink. That process has to be run in cycle. Now Carnot cycle is following this kind of cycle. It goes from A to B through an isothermal process, then again B to C through an adiabatic process, then C to D through an isothermal compression, then D to A again isothermal or adiabatic compression. To visualize this Carnot cycle, we have to visualize a schematic diagram. We have to draw a schematic diagram to visualize the Carnot engine. Now the basic objective আসলে কি, what is the objective of the Carnot engine? The objective of the Carnot engine to realize or construct a heat engine that gives 100% efficiency. That gives 100% efficiency. The basic objective of the Carnot engine was to show that or to realize that I will get a 100% efficient, because already people মানুহ যিবিলাক heat engine develop কৰিলে তাৰ পৰা এইটো কথা গম পালে যে heat engine cannot give 100% efficiency. So Carnot, what he tried to do, he tried to make a engine that will give 100% efficiency. So that means he will convert all the heat to the work. So he will make such an engine. That is the basic idea. And for that purpose, this Carnot engine he considered to be ideal engine and theoretical. Ideal and theoretical. Theoretically proposed কৰিলে. He has proposed the engine theoretically. That means it is a theoretical engine. First of all, তাৰপিছত practically implement কৰিব পাৰি নে নোৱাৰি, that is different issue. But he has proposed a theoretical engine, and he also called it an ideal heat engine. Ideal in the sense that the gas that will be used will be a perfect gas. Okay, whatever gas that will be used in the heat engine, that will be a perfect gas, which is an ideal case. Also, processes are reversible. Reversible process বুলি ধৰিলে no loss, কোনো loss নহয় বুলি ধৰিলে. So he make all possible idealized case. যিমানখিনি পাৰে গোটেইখিনি ideal কৰি পেলালে. There will be no loss of due to the friction and all. It's a perfect gas. Processes are reversible. So there is no way of getting the getting away from the ideal situation. So he has strictly stick to the ideal situation. So it is an মানে মানুহবিলাকে ভাবি লৈছিলে যে okay, the heat engine cannot give me 100% efficiency because of maybe the case that there is a loss due to the friction. Gas to this is not a real ideal gas. Real gas or some efficiency কমিব পাৰে. Processes are irreversible. তার কারণে efficiency কমিব পাৰে. So he cannot take account of all these possibilities. So he considered it to be a perfect gas, reversible process, no loss due to friction and all. Now after considering these things, he start constructing the engine. Hey engine to কেনেকৈ construct কৰিছিলে? For that engine, he has visualized the engine like this. You have to have a source. এটা source আমাক লাগিব, because we know for a heat engine we need a source, we need a sink, and we need a gas. So মোক এটা source লাগিব, then I need a sink, then I need a adiabatic stand. এটা adiabatic stand লাগিব. It is called adiabatic stand. Adiabatic stand. We know the process. আমি Carnot cycle আমি জানো. Carnot cycle to আমি জানো. We know the Carnot cycle already we have discussed. Carnot cycle means we have to go from a state A to state B through an isothermal expansion. It will expand. Then it will go from B to C through an adiabatic expansion. Then it will go from C to D, isothermal compression. Then D to A, adiabatic compression. So this is my cycle. I know this cycle. That means I have to complete this cycle. Every cycle will complete korbo laga hoy. This cycle consists of two processes. One is isothermal, another is the adiabatic. Prothomote isothermal expansion hobo, then it will be adiabatic expansion, then again isothermal compression and adiabatic compression. So I should have two processes, isothermal and adiabatic, and that is why I need an adiabatic stand here. Adiabatic stand amok lagibo to visualize the adiabatic process. Now I need a cylinder with a piston. The piston logot I need a cylinder. The heat can go like this. Heat can enter this surface. These are adiabatic walls. So heat cannot go by other sides. Heat can only transfer through this side. Etu side er majore heat to hoy humao pare নহলে ulao pare. So there will be a transfer of heat through this face only. There will be no way of transferring heat from the other faces. Baki bilak face er heat to jabo noare. So we have a source here. Source means this is a reservoir. Ami jotla chasilu. Here is reservoir which will have a temperature, let it be T1, and I have a sink which is again another reservoir which is at temperature T2. Now T1 is greater than T2. Okay, so this is the things that I need here for a heat engine to operate. That means to Carnot engine to operate, I need these things. I need a source, sink, adiabatic stand, and the gas. I need a gas here. Now what is this gas? This is a perfect gas. Okay, and whatever process will follow here, isothermal expansion, adiabatic expansion, all will be reversible. All are reversible process. So let me assume that let the initial temperature of the gas is Ti. মই gas eta loisu and the temperature of the gas is Pi. Now how I will visualize the whole process you see. First of all, okay, আমি কি কৈছিলো যে source and sink are reservoir আৰু সেই source and sink to reservoir হয়. Reservoir has a property that if you take heat from the reservoir, the temperature will not be affected. Last class আমি discuss কৰিছিলো reservoir পৰা মই temperature heat যদি লৈও লওঁ বা heat যদি এডো কৰোঁ, then there will be no change in temperature. কিন্তু গ্যাসত যদি মই এই গ্যাসত যদি মই হিট অ্যাডাপ্ট কৰোঁ তেতিয়া হলে ইয়াৰ টেম্পারেচাৰটো কি হ'ব চেঞ্জ হ'ব and if I extract heat from the gas its temperature will change, but that is not happening in case of the source and sink. This is a reservoir heat add কৰা বা extract কৰা, there will be no change in temperature. This is the property of a reservoir. First of all তুমি কি কৰিবা, you put this whole cylinder over the source. You put this whole cylinder over the source. And what is the temperature of the source? Temperature of the source is T1. What is the temperature of the gas? Temperature of the gas is Ti. Okay. So I will put this এই গোটেইটো মই কি কৰিম, whole cylinder I will put over the source and I will let it be like that. Hetu jodi hoy, then after some time what will be the temperature of the gas? I am putting this whole cylinder over the source and I am keeping it like that for some time. Then after some time what will be the temperature of the gas? T1. Okay, because it will take heat from the source of the heat level, it will go to the equilibrium state. And equilibrium, now the temperature of the gas will not be Ti, it will become how much? T1, and that is my starting point. This is the temperature T1. So I will start from that situation. So what situation I will start? I will put the gas over the source and let the gas equate the temperature of the source, so that the temperature of the gas become how much? T1, equal to the source. So whenever the temperature of the gas is equal to the source, will there be any exchange of heat? Kiba heat exchange hobo ne? Nohoy ban, because the temperature of the source and temperature of the gas and the temperature of the source both are same. Very same hoy, there will be no transfer of heat. Kidu movie ki lagibo, I need a isothermal expansion. So that is my starting point. What is my starting point? The starting point is that the gas temperature of the gas is T1. Starting point to ki hobo? Starting point is the temperature of the gas is equal to temperature of the source. Temperature of the gas is equal to the temperature of the source. This is my starting point. Now, if you want to expand the gas isothermally from that situation, from which situation? From the temperature T1. Now the gas is at temperature T1. The gas is at temperature T1. Now if you want to expand it isothermally, what you will do so that now the gas will expand isothermally from A to B. What you can do now? You have no other H, echo baki H tumalokor hatot nai. You have only the source and you have only the cylinder here. And the temperature of the gas is equal to the temperature of the source. Now I am asking you how you will start the isothermal expansion process. There is no way of adding heat from outside. Just source report ase, the cylinder is over the source and the temperature of the gas and the source is same. Now I want to make it isothermal expansion. How how you can do it. You have to change the pressure. That means this weights you have to reduce. এই জন্য প্রেসার পড়ে আছে না এটা, this weight to তুমি কি কৰিবা reduce কৰিবা. If you reduce the weight, the pressure on the gas will be now reduced and it will what? Expand. It will expand. So reducing the pressure over the piston, I am reducing the pressure. As the pressure is reduced, the piston will go up. So whenever piston goes up, temperature of this is into gas আছে, এই temperature of the gas to কি হ'ব try কৰিব, কমি যাব try কৰিব. So once the temperature of the gas try to decrease, then T1, at that moment this will provide heat because it is a temperature T1, no? So here temperature to কমি যাব try কৰিব because this is in contact with this. এইটো ইয়াৰ কণ্টেক্টত আছে, সেইটো সময়ত কণ্টেক্টত থকাৰ সময়ত মই weight to reduce কৰি আছোঁ. So it is expanding. While this gas is expanding, temperature try to reduce, and temperature to reduce over try to. At that moment, as the gas is in contact with this, here পৰা heat to কি হ'ব? It will go to the gas. Gas will go and it will maintain the temperature at T1. We got the point? There will be expansion. If expansion হোৱাৰ লগে লগে কি হ'ব? Temperature কমি যাব try কৰিব. কিন্তু at that moment, যে temperature কমি যাব try কৰিব, the source will provide the required heat to maintain the temperature at T1. Because this is a very, very slow process. Very, very slow process. গতিকে মই slowly weight to reduce কৰিম, I slowly reduce the pressure and automatically কি হ'ব? As the temperature of the gas reduce, source of the লাহেকে heat কি হ'ব? It will transfer from the hot region to the cold region. So it will maintain the temperature of the gas. So that means both will be in equilibrium. We got this point or not? Okay. So let me expand it very small, little bit. I expand korilu, and it goes from here to here. It goes from here to here. ইয়াৰ পৰা ইয়ালৈকে গ'ল. So ইয়াৰ পৰা ইয়ালৈকে যোৱাৰ লগে লগে কি হৈ আছে? There is a expansion, change in volume, but temperature কি হৈ আছে? Same হৈছে T1. Because temperature কমি যাব লাগিছিলে, কিন্তু the source will provide the required heat so that the temperature will be maintained at T1. তাৰপিছত মই আকৌ weight to reduce কৰিম. আকৌ weight to reduce কৰি পেলাই আকৌ কি হ'ব? There will be again expansion. আৰু আৰু যে expansion হয় তেতিয়াহ'লে temperature কি হ'ব? আৰু reduce হ'ব try কৰিব. And at the same moment, আকৌ source কি দিব? Heat will provide by the source and the temperature will be maintained. So like that, I will make a small expansion because it has to be a reversible process. But again, more small step of the. So I will go in a small steps, more little bit like expand koram, and at the same moment the temperature is maintained. Kori, I will go to this position or state B. I will go to this state B. State B ke modam. So small expansions. So go to small expand kori. Ultimately, I am going from state A to state B. So there is a expansion. You see, it is volume V1, and this is volume V2. Volume is expanding from V1 to V2, but temperature to it is maintained at T1. So it is an isothermal expansion. So I have an isothermal expansion from A to B. During that isothermal expansion, my volume has changed from V1 to V2, but temperature remains constant at T1. And he gote process to does the gas taking heat? Gote process to air pura B loke jete gas to goi ase. He homoyot gas to heat loi ase ne nai? It is taking heat. So let the amount of heat that is taken by the system is Q1. So now you see, now the system means the gas is going from state A to state B. It is expanding from state A to state B. Temperature maintained at T1 and it taken heat how much? Q1. So heat low ase, kintu temperature to ki hoye ase? constant হৈ আছে. So this is an purely a isothermal expansion process. Heat লৈ আছে, expand হৈ আছে, but temperature is still maintained. কেনেকৈ মেইনটেইন হৈ আছে যে এইটো বাঢ়িব, বাল্বটো এক্সপান্ড হোৱাৰ লগে লগে ইয়াৰ পৰা হিট ইয়াত সোমাই যাব. চ' টেম্পাৰেচাৰ মেইনটেইন, আকৌ এক্সপান্ড হ'ব, আকৌ ইয়াৰ পৰা হিট সোমাই যাব, আকৌ ইট উইল মেইনটেইন. চ' লাইক ডেট দ্য টেম্পাৰেচাৰ উইল বি মেইনটেইন. চ' আই কেন নাও নাইচলি গ' ফ্ৰম এ টু বি. চ' মই এটা কিবা এটা ভলিউমলৈকে মই গ'লোঁ আৰু চাম ৰিকুৱাৰ্ড ভলিউম. চ' আই হেভ এলাউড দ্য গেছ টু এক্সপান্ড টু এ চাম ৰিকুৱাৰ্ড ভলিউম V2. V2লৈকে মই এক্সপান্ড হ'ব দিলোঁ. এতিয়া মইতো আৰু এক্সপান্ড হৈ থাকিব দিব নোৱাৰোঁ. আই হেভ টু কাম বেক টু দ্য ইনিচিয়েল ষ্টেট, বিকজ দিছ ইজ দ্য প্ৰপাৰ্টি অফ হিট ইঞ্জিন. হিট ইঞ্জিনটো তোমাৰ কি হয়, ইনফিনিট টাইমলৈকে এক্সপান্ড হ'ব দিব নোৱাৰোঁ. ইট হেজ টু এক্সপান্ড ফৰ চাম টাইম, দেন এগেইন ইট হেজ টু কম্প্ৰেছ. নাও আফটাৰ ৰিচিং B, what we will do, this gas will be put over the adiabatic standard. সেই গেছটো adiabatic standard ওপৰত তুমি থ'ব লাগিব. This whole system has to be placed over the adiabatic standard. এতিয়া adiabatic standard ওপৰত যদি তুমি থোৱা, মই কৈছোঁ যে ইপিনৰ পৰা there is no way of transferring heat from these other sides, only way is this. গতিকে এই গোটেইটো মই ইয়াৰ ওপৰত দি দিম. So if I place this whole cylinder over the adiabatic standard, now there is no way of transferring heat from the gas to the surroundings. Because মই তাক adiabatic standard ৰাখি দিলোঁ. এটা মাত্ৰ ৱে আছিলে এইটো, সেইটো মই এতিয়া ক'ত কৰিলোঁ, adiabatic standard থৈ দিলোঁ. Now again I will allow it to expand. এতিয়া তুমি আকৌ এক্সপান্ড কৰা, তুমি ৱেটটো ৰিডিউচ কৰা, and allow it to expand. এতিয়া তুমি যদি ইয়াক এক্সপান্ড কৰা, what will happen to the temperature? It will reduce, because now there is no way of giving heat to the gas. তুমি যদি এক্সপান্ড কৰি আছা, now there will be a decrease in temperature. So adiabatic standard ওপৰত যেতিয়া মই থ'ম, থোৱাৰ পিছত যেতিয়া মই এক্সপান্ড হ'ব দিম, I will allow it to expand, then the temperature of the gas will reduce. মই এক্সপান্ড হ'ব দি থাকিম up to what temperature? Up to the temperature of the sink. So whenever the gas reach the temperature of the sink, তেতিয়ালৈকে মই গেছটো কি কৰিব দিম, এক্সপান্ড হ'ব দিম. Now whatever expansion is there occurring, এইটো কি টাইপৰ এক্সপানশ্যন হৈ আছে, adiabatic expansion হৈ আছে, because temperature is changing. So now this is called adiabatic expansion. আৰু সেইটো মই কেতিয়ালৈকে হ'ব দিম, যেতিয়ালৈকে the temperature of the system becomes the temperature of the source. Once the temperature of the gas is equal to the temperature of the sink, I will stop the expansion. Okay, and that is this one, B to C. So B পৰা C লৈকে যোনটো এক্সপানশ্যন তুমি হৈ আছে small stepত, এই এক্সপানশ্যন কি হৈ আছে, temperature is changing from T1 to T2. Temperature is changing from T1 to T2. Pressure, you have to reduce the pressure, then only it will expand. If you want to make it expand, then you have to reduce the pressure. সেইকাৰণে মই কৈছোঁ ৱেটটো কমাব লাগিব. I have to reduce the weight, that means I am decreasing the pressure, so it is expanding. So that is why it is expanding and coming from B to C, and temperature has been reduced from T1 to the T2. Okay? So is it clear up to this point C? A পৰা B লৈকে আহিলোঁ through isothermal expansion, B পৰা C লৈকে আহিলোঁ through adiabatic expansion. এতিয়া মই কি কৰিম, I will make the compression. That means I will start my journey to the initial state. সেইটো কাৰণে মই আকৌ কি কৰিম, then again I will put this whole cylinder over the sink. মই সিঙ্কৰ ওপৰত দি দিম, because now the temperature of the gas is how much, T2. Temperature of the sink is how much, T2. So there will be no exchange of heat between them. So I will put the cylinder over the sink. Again, now you do one thing. Now you increase the weights, because I have to make compression. Here you weight to increase. You increase the weights very, very slowly. So very slowly to be weight to increase. The amount of heat or here the amount of energy এইটো কম্প্ৰেছ কৰাৰ লগে এনাৰ্জিটো কি হ'ব বাঢ়িব ট্ৰাই কৰিব ন সো যিখিনি এক্সেছ বাঢ়িব সেইখিনি ক'ত যাব it will be taken by the sink but the temperature of the sink will remain what same because reservoir to heat dileও কি হয় temperature so I will allow this gas to compress over this gas over the sink and during that process the gas will give certain amount of heat to the T2 here tomar heat দিব so it is Q2 so Q2 amount of heat will be given to the sink during the compressing process now compress kori kori aso and I am compressing in such a way so that it again the gas is again come back to the volume V1 initially more to V1 asil so it will be coming up to this not V1 V3 this is V1 this is V2 this is V3 so V3 up to a certain volume V3 I will compress it to up to a certain volume V3 মই যাতে volume to V2 পৰা কমি V3 লৈকে আহে so I will compress the gas up to V3 this is my V1 this is V3 this is V2 sorry this is V2 this is V sorry this is V3 and this is V4 this is V4 V4 this is V2 V2 and this is V3 this is V3 so it is the gas is coming from A to B means it is coming from volume V1 to V2 then from B to C it is expanding from volume V2 to V3 then V3 or V4 it will compress from V3 to V4 and during that compression there will be a release of heat Q2 to the sink of kiman heat release koribo it will release Q2 amount of heat and source of kiman heat loi ase it is taking Q1 amount of heat so during the isothermal process only it can take heat so during the isothermal expansion from A to B it will take Q1 amount of heat during the adiabatic expansion from B to C there will be no exchange of heat then from C to D there will be isothermal compression during that process Q2 amount of heat will be given to the sink after that you again bring this whole cylinder and put it over the adiabatic stand আকৌ adiabatic stand তুমি থৈ দিয়া থৈ পেলাই again you compress it এটা তুমি ইমানখিনি compress কৰিব লাগিব so that the temperature will increase হৈ কিমানলৈকে increase হ'ব লাগিব it has to increase to the source temperature so I'll put this gas from here to here and I'll increase the pressure with to बढ़ाई दिम and the temperature will increase from T2 to T1 T2 by T1 हो and volume will go from V1 V4 to V1 so now again you are coming back here ইয়াত তুমি আকৌ L কে আহি গলা so যেতিয়া তুমি L কে আহি গলা তোমাৰ প্ৰেসাৰ কিমান হৈ আছে প্ৰেসাৰ is suppose কিবা এটা আছে P1 now volume is V1 and temperature is again T1 and it is not affecting the surrounding temperature hetu ase there is no effect of the surrounding because here temperature T1 ase here temperature T2 ase and this is the only surrounding to this gas baki ibilakot to tumar eko hoboi nware because this is adiabatic one to ipine eko jaboi nware only way of transferring heat is this one আর হেতুর কারণে ইয়াত কোনো এফেক্ট হয় নাই ইয়াত কোনো এফেক্ট হয় নাই that means there is no effect in the surrounding and the system is coming back to the initial state so this is a purely a reversible process so during the coming back to the initial state there is no change in the surrounding and no change in the state মানে system তো একো চেঞ্জ হয় নাই এই আগৰ জায়গালৈকে আহি গৈছে so system is coming back to the initial state there is no change in the surrounding so it is a purely a reversible process so কেনেকৈ কৰিলো মই কামটো গেছটো মই ইয়াত থলো তাৰ পিছত গেছৰ টেম্পাৰেচাৰ যেতিয়া ইয়াৰ সমান হ'ব সোৰ্সৰ সমান হ'ব then I will allow the gas to expand it will expand হৈ it will go to volume V2 তাৰ পিছত I will put it over the adiabatic stand Again, I will allow it to expand. Now the temperature will change. Temperature will change. I will allow the temperature to decrease up to the temperature of the sink. Sink or temperature to pai jabo, then again I will allow the gas to compress. Gas to compress korim. Keneke compress korim? Isothermally compress korim. So isothermally compress korar pisot it will come to the volume V4, and after that, now again I will put the gas over the adiabatic cell and I will allow it to compress adiabatically and will go to the initial state A. So I am completing one cycle. A complete cycle complete process. I have completed one cycle, and during that cycle, during that one cycle, Q1 amount of heat is taken from the source, and Q2 amount of heat is given to the sink. So during one complete cycle, the gas is taking heat Q1 from the source, and it is releasing heat Q2 to the sink. Work done kiman hobo? So what will be the work done? Work done in one cycle. Let it be dW. Kiman hobo? Q1 minus Q2. So Q1 minus. So one cycle immediately work done kori ase. Eta next ei cycle ta ako repeat kora tumi. Repeat kore aru ki paba? Ako work done paba. Aru repeat kora ako work done paba. So if you repeat the cycle, you are getting work done by the heat engine. Ei engine to tomak work done di thakibo. So this is what is called the Carnot engine. Etia ami ki bolabo lagibo? We have to find out the expression for efficiency, because Carnot's objective to assume that the engine will give me 100% efficiency. He was confident. So whatever engine I am proposing, that engine has to give 100% efficiency. So he has to show it that it is 100% efficiency. But he has to find out the expression for efficiency. Our efficiency expression to what I need the W by Q. So in this case, at a cycle if I see for one cycle, then the total work done divided by the total heat taken. Kiman heat lo ase? Q1 amount of heat lo ase in one cycle. Kiman work done kori ase? W. So if I can show that eta is equal to 1, if Carnot can show that eta value is equal to 1, that means Q1 amount of heat will be like W amount of work kori ase, and Q1 is equal to W, then very nice, it will be having 100% efficiency. So তার কারণে আমি এটা কি করব লাগিব? তার কারণে আমি প্রত্যেকটো স্টেপত আমি work done to উলিয়াম, because this is adiabatic expansion, so ইয়াৰ work done হ'ব. Let it be W1. Let it be W1. This is W1. ইয়াৰ পৰা ইয়ালৈকে আহিলে another work done হ'ব. This is with W2. ইয়াৰ পৰা ইয়ালৈকে হলে another work done হ'ব W3. ইয়াৰ পৰা ইয়ালৈকে গলে another work done হ'ব W4. So total work done to কিমান হ'ব এতিয়া? W1 plus W2 plus W3 plus W4. So total work done will be W1 plus W2 plus W3 plus W4. So W is equal to, this W is equal to W1 plus W2 plus W3 plus W4. So I have to find out all these expressions. W1, 2, 3, 4. তাৰপিছত মই সেইকেইটা গোটেইকেইটা 8 কৰিম. তাৰপিছত মই Q1 যোনটো আছে, Q1 ৰ কিমান এমাউণ্ট অফ হিট লৈ আছে মই সেইটো চাম. And if those values are equal, that means if W is equal to Q1, then I can say that the efficiency is 100%. But যদি সমান নহয়, then I have to say that okay, you have proposed that it should have 100%, but it is not 100% efficient. It is not 100% efficient. But this is an ideal case. This Carnot engine is an ideal engine. So ideal case loss. There is no loss, perfect gas, all are reversible process, everything. Because here loss or so we should get 100% efficiency here. I mean 100% efficiency power, because there is no loss. and all are ideal case. Okay. So, here I come to next. What we have to do? We have to find out the expressions for this W1, W2, W3, and W4. Here already I mean two expression work done. Isothermal expansion work done. Expression to jano. We also know the expression for adiabatic work done. So isothermal lagane ki asile ln of V2 by V1. Adiabatic lagane ki asile nr by gamma minus 1 into T1 minus T2. So I have the expression for work done, and I will use those expression for work done to find out the amount of work done during the whole process. Here to sum up, here 4 process 1, 2, 3, 4, and these are called strokes. So here to kiman stroke engine hoy, this is a 4-stroke engine. 4 stroke it is coming back to the initial step. গতিকে ষ্ট্ৰোক যিমানে বেছি হয় সিমানে তোমাৰ ইঞ্জিনৰ এফিচিয়েন্সিটো কি হ'ব বাঢ়িব। এখানে আমাৰ বাইকবিলাকৰ কি হয় ইট ইজ 1 ষ্ট্ৰোক অৰ 2 ষ্ট্ৰোক, কিন্তু কাৰবিলাক হয় কি 4 ষ্ট্ৰোক ইঞ্জিন, 4টা ষ্ট্ৰোকত কাম কৰে, 4টা বেলেগ বেলেগ প্ৰচেছতো যায়। সো ইয়াতে তোমাৰ কি হৈ আছে ইউ হ্যাভ 4 ষ্ট্ৰোক, এটো এটা ষ্ট্ৰোক, ইট ইজ 1 ষ্ট্ৰোক, ইট ইজ 1 ষ্ট্ৰোক, another ষ্ট্ৰোক। সো দিস 4 processes are called 4 strokes. So it is a 4-stroke engine. Carnot engine is a 4-stroke engine. Okay. So let us stop it here today, and next class we will find out the expression for work done.